something else, like finding a midpoint or something. Again, you just don't use the ruler the way you normally do in this class.
Got it.
All right, so let's see what else here. Okay, so it looks like 9. I'm not sure what you got wrong on 9. We can look at what it's actually asking you to do. So first thing is, it'd be nice to know what is a rhombus, but maybe that's not. Oh, okay. You got to actually go through and do this. So generally the correct way to create a rhombus is you have to copy the angle, but you can't just copy it anywhere. You have to copy it at R. So basically you got to swing an arc from there, from Q to R, and swing another arc. And then you extend this line with a ruler. And then you copy the angle again, like we were showing earlier. So you would want to copy the angle in such a way where you got these two arcs to intersect. And then you've got to draw a parallel line from Q to R up here through some other points. So I guess the challenge here is to follow the steps, fix the compass at L, and adjust its width to point M. Okay, I'm sorry, that's what you just fix the compass at M and adjust its width to L. Okay, so basically they're saying to swing an arc like this. All right, without changing the width of the compass, move to N. Okay, so they're and draw a small arc in the big arc, label the point of intersection through arcs as T. Okay, where's T? They don't have T on their picture. So, okay, so the best way to help you, unfortunately going backwards isn't going to be all that helpful, but we would want to like follow these steps from each student. Because there's actually a lot of ways to, but essentially you need to copy the angle.
So would like the most accurate way to do this would be to like follow the steps that each person says and then see when one's
Yes,
correct.
but you kind of need to know what to look for. Like you have to copy the angle and you have to draw parallel lines at some point. And then you also need to keep the lengths the same. And that's maybe something you don't know yet because a rhombus has 4 equal sides. But
Got it.
this would be pretty challenging to do without actually doing it. Like you would want to almost follow their steps, like you said.
Got it. Because this one was not one I was kind of like guessing on because I didn't know how to properly do it.
Yeah. That's what the point be. And there's this very specific way that they're doing this. So there might be something in the notes or the videos to do
Yeah, I
this.
think that might come up a little bit later in one of the like actual lessons.
Yeah.
All right. Any
All right.
I
So
think the
do
next
you want
one.
us to, yeah, do you want us to go through 10?
Yeah.
Sure. Okay. Let's take a look here. These are, I'll just say, and these are so tough without like having a compass and protractor to try with. They're just, and having some guidance. So Alice is designing a bookshelf. The segment L to Q represents the base of the bookshelf. Alice wants to construct a line to represent a rack passing through R and parallel the side LQ. She uses a straight edge and a compass to complete some of the construction as shown. So she wants to construct something that's exactly parallel to LQ. Do you agree with that?
Yeah.
Okay. Now what it looks like she's done is she sort of copied PS and she's really close to copying the angle. Like she's trying to copy the angle here. That's what I'm seeing. Like this
Yeah.
and this. Um so how do we want to proceed here? So I'm looking at the answers here. So it says place the compass at N. I'm sorry, the one you chose without changing the compass with the compass at P and draw an arc. Let's just fix the compass at P and draw an arc. place the compass at S and adjust its width to point P. Okay. So why are they doing it this way? Place the compass at S and adjust its width to P. So they're basically saying go right here and swing an arc like this. Is what I'm seeing.
Got it.
But why, that it's like they're not giving enough information here to this. Let me just check one thing here because well, and who is the school through? Is this an online?
Chandler Online Academy.
Okay, got it.
Yeah, so let's do the
Okay,
Chandler District's
okay.
USD.
All right. So let's see if we can move past. And let's go to 12. All right, so 12. All right, so here we go. I think, let's see why you're straight. So Ethan is using his compass and straight edge to complete a construction of a polygon inscribed in a circle. Which polygon is he in the process of constructing? I can see this is very tough. So it looks like he started here and swung this arc first, and then this arc second. And what maybe isn't obvious, but if you were to go all the way through, it looks very much like he was trying to go through the center of the circle. That's how he knew to do this. Um, so I guess he might be trying to draw something like that, which is what they're suggesting here by the answer. And the reason is because if all radii are the same, which is an obvious thing to say, but that appears to be where they're going with this one. You can get a hexagon inside here. In fact, that's a common problem. You can even get a square, but I think we're supposed to look at the fact that he probably got these red lines from getting swinging a radius arc. I don't know. It's a little bit unclear. You're not getting like full information, I would say. But so it looks like you did okay. Just constructions. Oh, and then paragraph proofs. Okay. We should talk about proofs next. And you got a 2-column proof. Okay. All right. So we should talk about what each of these answers means so that you've got some background for them. All right. So these all four of these refer to two parallel lines with a transversal cut through them.
Got it.
Did you see anything like this in class? I know you said you just started, but anything like this or from a previous class maybe?
Yeah, I think so.
Okay. So alternate interior angles are the following. There's a bunch here. So angle 4 is congruent to angle 5. So these alternate over what's called the transversal.
Okay.
And this is the interior region. And then the other ones are the exterior regions. Is reasonable. But there's more than one set of alternate interior angles. There's 3 and 6 also. And you're expected to know that. You're supposed to say, okay, I got it. I don't see it. But they should cover this at some point. Corresponding angles. So let me actually kind of reframe this a little bit here. So corresponding angles. 1, 2, 3, 4, 5, 6, 7, 8. So the corresponding ones, they are, think of it as like, imagine, let me draw. It's like, imagine you're here and your friend's here. And it's like 1 corresponds to 5 because they're both kind of top left. So I'll write that here. And these are congruent. Angle 1 is congruent to angle 5. Those are corresponding. Same with like 2 and 6, they're top right. Same with 3 and 7. Okay, and it's like same idea, bottom left,
Yeah, top right, yeah.
right. And but this only applies if the lines are parallel. They have to be parallel for this to apply. Angle
So
4
if
and
one of
angle
them's
8.
like skewed even a little bit, then it'd be
That's right. That's right. And then you'll also learn about what's called the converse, which is if you can prove, for example, that 1 and 5 are the same, then by the converse, these lines are parallel. But we're assuming that they are parallel for the moment. Vertical angles is the next one on your list here. So vertical angles, 1, 2, 3, 4, 5, 6, 7, 8. You'll see them labeled differently in books, but it's all the same. So vertical angles would be like angle 1 is congruent to angle 4. Vertical means they sort of meet at a V. I don't know if that's clear or not. Angle 2 is congruent to angle 3. They meet at a V.
got it.
Same thing down here. Angle 5 congruent to angle 8. Angle 6 congruent to angle 7, stuff like that. So there's kind of two, and we're gonna talk about the same side interior angles, but I gotta make a quick comment here. Kind of two things in geometry that you're gonna do over and over again. You're either gonna set equal or they add up to something. Like there's not a lot of algebra in this, a little bit, but you've got to remember these things. You either set it equal or they add up to something. So the last type of angle relationship, 3, 4, 5, 6, 7, 8, is called same side interior. And so here's the interior. Here's what that means. It means that angle 3 plus angle 5 add up to 180. So notice no longer congruent, they just add up. Same with angle 4 and angle 6, they add up to 180. Same side refers to the fact that they're on the same side of the transversal.
Got it.
Okay, so we can now go back to this proof and try to answer it, but you need to know like what those things are. So let's try to do that here, and I'll do that in pieces here. I know this is a lot to be thrown at you in a short amount of time, but let's see how you do. Okay, so notice that JK and HI are parallel, okay? And we want to prove that angle JNM, that's this one here, is congruent to NMI, this one here. So those are alternate interior angles. Those are alternate interior angles, but you can't just say that. They're trying to say like, okay, let's see. Actually, I take that back. That is what they're looking for. They wanted you to just know which one, what's the name of these. And I think, having this list here would have really helped, right? It's like, how do you do it if you don't know the definitions? Well, now you know them. So it was literally just looking for you to say alternate interior angles, like they're alternate and interior.
Got it.
So let's look at 19. 19 actually is a proof. Let's see here. Snip this in. All right. So examine the 2-column proof. So they're telling you that this line is parallel to this line. That means all the stuff we just talked about is there. Now, statement 4. Okay. All right. So it says line JK is parallel to line LM. That's given. Usually the given is always put in the first position, almost always. Now the next thing it says is that angle 1 is congruent to angle 4. Those are vertical angles. Do you agree with that from earlier?
Yeah.
Okay. And then it says that now angle 4 is congruent to angle 8. Well, these are corresponding. they correspond. They're in the same relative position. So you can think bottom right, bottom right. Now angle 1 is congruent to angle 8. Well, if 1 is congruent to 4 and 4 is congruent to 8, that means that 1 is congruent to 8, and that follows from the transitive property. But it's like if A equals B and B equals C, then A equals C. That's the transitive property. And this is something you might have seen in a previous course, maybe not. Yeah, it's hard to say here.
All right.
Now, a problem like 20, I know you got it right, but was 20 a fairly easy problem for you where you had to find the angle measure?
Yeah, because I just took 90 and then I took 90 degrees, then I subtracted the 52 degrees from it to get the 38
Right,
degrees.
right. So geometry is broken up into really well, I'll just say two main forks. There's the numerical side, which is where students who are strong in algebra really like. And then there's like
Yeah.
the other side, which is proofs, instructions,
Yeah, I
things
think that,
that,
yeah, the numerical side is the one that I'm a little more stronger in than
yeah,
the
right.
proofs
Most of your
construction.
issues tonight were in over here. It's just, and this is because it's very different. It's
Yeah,
like
it's kind of new compared to
you
the
can't,
empirical.
what you can't do in geometry is say that two things are the same. You have to prove that they're the same, and that's very, very frustrating for most students. So
No, because in like,
um,
yeah, because in algebra 1, they're like, both of them are equal. That's a given. And then you have to like just, you're basically making them two equal. But now you have to like prove
exactly,
that
exactly.
they're equal.
All
Yeah.
right. So good